Okay, in this video, I'm going to show you how to create a drill in Fusion 360. We're in the manufacturing workspace right now in Fusion. So if you're in design or something else, make sure you switch over to manufacture. That way we have all the tools that we need. Okay, in a previous video, I talked about we have to go into tool library. Okay, so we're going to keep doing that. Anytime we make a new tool, go to tool library. You want to pick which local tool library you want to use. I have a couple of them here. For the purposes of these videos, I'm using one called Manufacturing that I made. And if you remember, to make a new one, you right click on New Library and give it a name, and then start putting tools in there. All right. So all we have right here is one tool, flathead mill. So I'm going to go with just a regular drill bit, twist drill. So all we got to do is the plus sign, click on Add Tool, and down here under Hole Making, Drill. Click on that. And we're going to put a description of what we want. We want to do a 1/4 inch twist drill. That's all we have to put on this one. Go to cutter information. Type is a drill. It's in inches. As far as units goes, clockwise rotation. Number of flutes is 2. HSS, high speed steel. We're going to keep it that way. All right, 1/4 inch drill is 250 thousandths. So under the diameter, I'll put 250. Tab forward, that'll change. The tool diameter and the shaft diameter are the same. As far as the lengths go, I'm not too concerned about right now. We're doing some pretty basic stuff, so I'm not too worried about the length of the below the holder or the flute length or all that. That's all fine. We skip over shaft, we skip over holder, and we go right to cutting data. All right, spindle speed. I'm going to change our surface speed to 200 because it's aluminum, and that gives us a spindle speed. It calculates it for us at 3,000 RPM. As far as feed per revolution, if I look up at my drill chart, I believe it's 0.002 is our feed per revolution for a drill this size, and that changes it to 6 inches a minute. All right. So it's not really aggressive. It's kind of slow, actually. But you know what? For what we're doing, it's okay. Coolant is on flood, always on. That's good. So that's all good. We have a good cutting data. Now, post-processor, all we got to really do is put a number in there. You can put any number you want. I'll just change it to 4, tool 4. It doesn't matter. It's something we can change in the long run. Anyways, you can put in a comment here that will appear on the program. 0.250 diameter drill. Whatever you want. You don't even have to put that in there if you don't want to. And then accept it. And there it is, right there. So while we're doing twist drills, we might as well also in this video, just so quick, we can also do a spot drill, different type, but we'll do the add button again. This time we're going to go to spot drill, and we'll say it's a 3/8 inch by 90 degree spot drill. Better. 2 flute. Diameter is 0.375. And tip angle, we want to change that to 90 degrees. Okay, we want to make sure the tip angle is correct because that does make a difference for our depth. Shaft and holder will skip. Cutting data is 200 surface speed, gives us a 2,000 RPM. That looks good to me. Cutting feed rate, my chart, I believe it's 0.003 per tooth. Gives us a 12 inches per minute feed rate. That's fine. Post processor, we'll leave that at 2. That's fine. It doesn't matter what we use. As long as it has a tool, as long as it has a number on it, we're good for now. Accept. And so now we're starting to build up bit by bit. And that's how you do it for drills. Pretty straightforward, whether it's a regular twist drill or if it's a spot drill.